Okay. I think that was enough time. So I said who I am. Richard, you are next. And then you can pass it to whomever you think.
That means very good. So kia ora, that means be of good health. So kia ora, everybody. My name's Richard London. I'm the Manager for Building Performance at the Ministry of Business, Innovation and Employment here in New Zealand. We are the national regulator and advise government on Building Act and Building Code. I'm very pleased to be with this meeting. I'm going to send it across to Brodie.
Excellent, thank you. Good morning, everyone. I'm Brodie Hobson. I am a research engineer at Natural Resources Canada on Melly's team. And maybe I'll pass it on to our other team member, Sebastian. Or Eric, maybe, if...
Sorry, I was having issues. Sebastian Brito, team member with Brodie and Eric and Melly at Natural Resources Canada.
And Eric?
I'm Eric Sue. I'm a research affiliate at NRCan, working with Melly, Sebastian, and Brodie. I'll pass it on to Sally.
Hi, I'm Sally Semple. I work within the building safety regulator in the UK, dealing with principally with new buildings in England. And we have a large team here responsible for a number of building codes. And I work in particular with codes for energy efficiency, ventilation and overheating. And I will pass on to Vincenzo.
Hi, I am Vincenzo Corrado. I'm professor of building physics and building energy systems at the Polytechnic Torino, Italy. And I will pass the floor to Michael.
Michael. Thank you, Vincenzo. So I'm Michael Dodd. I'm a director at the Australian Capital Territory Government. I've been working on building codes here, primarily on energy efficiency for commercial and residential buildings. I'll pass over to, we have a visitor, and maybe hopefully will become further involved in future meetings. So Marsan, who's from the Commonwealth and Industrial Scientific Research Organisation, the CSIRO, who's a specialist in overheating, who I asked to come along today.
Yes, thank you, Michael. Hello, everyone. It's very nice to meet you all. I'm Maxan Sadeghi from Australia, working with Australia's National Research Agency, CSIRO. I'm leading Australia's overheating project for residential building. It's a great pleasure to be here tonight at in this meeting, and thanks to Michael and Melly for the invitation. Thank you, and I pass to Victoria.
Oh, hello. Hi, I'm Victoria Threadwell. I am a senior building scientist in Richard London's team. So we're at the Ministry of Business, Innovation and Employment in New Zealand. I'm actually dialing in from Christchurch, so way down the bottom of the world. And I am currently leading the development of an overheating assessment methodology for residential buildings, as well as tying it in with other projects. Sally, it sounds like we have a similar work program. We're working on ventilation as well as internal moisture at the moment, and also just general energy efficiency updates, all in parallel. I will pass it on to, who hasn't been? Roberto, have you been?
Hi, good morning. My name is Roberto Lamberts. I'm a professor of civil engineering, Federal University of Santa Catarina, South Brazil, working with building standards, regulations for energy efficiency in buildings, thermal comfort, and building simulation. And I pass it to Alexandra.
Hello, everyone. I'm Alexandra Maciel. I'm from the Ministry of Mines and Energy in Brazil, and I'm in charge of the implementation of the energy efficiency policy for buildings. I work at the coordination of energy efficiency here. and I will pass it to Hobson.
Brody. He went, so maybe. So this is a way to check if people are paying attention. No, it's not. Sarah?
Yes, can you hear me?
Yes.
Perfect. Yeah, Sarah Peterson. I work at the Swedish Energy Agency, and I work primarily with EU policy regarding like the implementation of EPBD and EED. And now, yes, who is left is the question.
It's okay. I can take
Yes.
it on. Ryan?
Yes, good morning. Ryan Kolker, Executive Director for Energy Resilience and Innovation at the International Code Council, model code development organization, and I focus on supporting our teams around energy efficiency and resilience and other things like offsite construction. Tristan hasn't gone.
Thanks. Tristan Grant. I'm the Director of Codes and Policy at New Buildings Institute, which is a nonprofit organization that works in the US and some internationally, primarily on energy codes and climate policy. We work with national model codes on those standards and codes development, as well as with states and local jurisdictions on their energy and climate policy development, adoption, and implementation.
Louis?
Yes, hello, I'm Louis Bourru from France. I'm working in CEREMA, a state agency working on building codes in carbon, overheating, and energy.
Thank you. Danielle? Maybe she's having a problem with her. Oh.
Can you guys hear me?
Yeah.
Yeah, okay, perfect. Sorry. I'm Danielle Crowell. I'm from the Office of Energy Efficiency at Natural Resources Canada. It's the non-research arm at NRCan.
Thank you, Danielle. Simon?
Yes, hello, good morning, and thanks for taking over, Melly. I was starting to feel unbearable pressure of trying to remember who'd gone before me. Simon Jones, I'm the head of the EXCO Support Services Unit, so the Secretariat for the EBC, which Melly chairs, so delighted to be here today. Thank you.
Thank you, Simon. Karin?
Hello. I work in a state agency in France with Louis Bourru, who was presented before me, and I work on building efficiency and particularly on adaptation for climate change for residential and non-residential buildings in France for temperate climate, but also for some islands in tropical climates.
Thank you, Karin. And
Sally?
Stanford.
Good. Hi, everyone. Stanford Harrison, Director of Buildings Policy in the Australian Department of Climate Change, Energy, the Environment and Water. And yes, we do quite a bit of work on new buildings. Overheating is in many bits of Australia, there's always overheating, but overheating is becoming an increasing issue, and sort of looking at how we adjust the code to cope with that is something which is the subject of a number of projects. And wonderful to see Masan is here today, and certainly very keen on learning from all you who have already worked out the solution. Looking forward to hearing it.
Excellent. Thank you. So before starting, I have a slight modification. I forgot to put Tristan on my list of speakers for our presentations. Tristan, would you be ready to be at the end after Ryan? Excellent.
Sure.
Excellent. Thank you. And if ever I forget anything, please remind me. There are lots of things that tend to forget. Anyway, so our first speaker would be Alexandra. Alexandra, you're ready to talk about what's happening in Brazil with for overheating. Excellent, thank you.
Thank you, Melly. Professor Lamberts, could you share the presentation, please?
And while that is happening, if you could, if everybody could send me the presentations. As you noticed on our EBC website, I have the presentations that have been made, as well as a summary of our meeting. And on occasion, I have the full recording, depending on the subject matter.
Can you see my screen now?
Not yet.
Not yet?
Not yet.
Excuse me, Melly, did we schedule the next meeting?
Not yet. I am about to send it. It's probably like the majority of people are going to be voted for the 11th of May. So it's a Monday. I'm going to send it right after these meetings, just in case there is something that comes up, so that I can include it in the agenda.
Thank you.
But since we have some technical problems, I don't know, maybe we can go to the next one and then talk too fast.
Yeah.
You're sharing your screen, but we are saying, yeah, excellent.
Sorry about that.
No problem.
Can you see it now?
Yep.
Yeah.
Alexandra.
Oh, thank you, Lambert. So we've brought our timeline about the implementation of our regulation policies. Although we've started the labeling program since the 80s in Brazil, it was only in 2009 and 2010 that we actually published the methodology for the label, energy efficiency label for buildings. And it was voluntary program, but since last year, we've published a new regulation in 2025 that established maps for buildings, and the instrument to make the compliance with the maps will be the label. And this label is conceived only to projects and after the building is built or retrofitted. And we are also now working on a regulation or a certification program for existing buildings, for buildings in operation, which is this DEO program, which is our next step. Next slide, please. This is our history on establishing maps for appliances and equipments here in Brazil. And it was like for the first time that we established maps for buildings last year. Next slide, please. This is our timeline for establishing these maps. So we are going to start with public buildings in 2027. The maps for public buildings will be the level way for energy efficiency. And from 2035, this minimum standard will be the NZEB, so the buildings will not only to have the level A, but we will also have to adopt at least to attend at least 50% of its primary energy demand with distributed energy, with renewables. local installed. And for private buildings, the minimum standard, the maps will be the level C. Next slide, please. This is just for you to understand how is our main scenario here in the country. So we have like most of the country presents a warm climate. There is a widespread use of natural ventilation as the primary cooling strategy, relatively low average residential electricity consumption. So it's around 150 kilowatt hour per month. It's partially associated with limited access to energy services. So it's related to energy poverty. And our climates are very different because we are a very big country. We are the only country in the world crossed by both the equator and the Tropic of Capricorn. So we have in the south of Brazil periods of the year very cold, where we have kind of snow, if we can say that. And we also have like desert climates in the northeast of Brazil. Next slide, please. So considering our housing sector, the envelopes are usually non-insulated. The low-income sector represents approximately 33% of residential buildings in Brazil. And the most common building systems used are ceramic bricks in the walls, ceramic tiles in the roofs, but we also have concrete roofs and walls, fiber cement corrugated sheets, and the glasses are single clear. And all these systems are considered in our national standards for building performance, which is the standard 15575. Next slide, please. There was this survey, which was very interesting because it showed us that regarding cooling preferences, 89% of the occupants here in the country prefer naturally ventilated environments at home, and the air conditioning is mostly used during the night. Next slide, please. So our national standard here in Brazil, we have this standard just for residential buildings. We are about to publish a similar standard for commercial buildings as well. And this standard is focused on minimum performance requirements, including a chapter dedicated to thermal performance. Although the Brazilian standards here are formally voluntary, they are widely treated as mandatory within the formal construction sector due to their linkage with the consumer protection legislation. But a significant share of housing production here occurs outside of the form, where compliance is much more limited. Next slide, please. And we also have the label. And because we've published last year this regulation that established the maps that adopts the label as its main instrument to show the compliance, actually the label is going to become compulsory, an obligation, because they will have to adopt this. So next slide, please. Considering our national standard. There was this review in 2022, and in the thermal performance chapter, we had some challenges to accomplish with. So we've tried to make a description of occupant behavior when modeling the hybrid strategies, because it was very important to consider the natural ventilated period. So the simulations using a reference building had to integrate this kind of different periods using natural ventilation and using air conditioning. And with that, next slide, please. We've tried to use the maximum use of bioclimatic strategies, so the thermal loads are counted only when natural ventilation was not sufficient to guarantee thermal comfort. So these are some of the strategies that we've tried to integrate and use to make the adjustments in this standard. Next slide, please. But we are still using, as the title says, the climate from the past, because we make the simulations using our climate data, not considering the changes that we are passing through. So the acceptable indoor operative temperature limits are defined as a function of the annual mean external dry bulb temperature. The simplified adaptive framework adjusts thermal comfort criteria according to the local climate, allowing higher indoor temperature in warmer climates. So we are very used to much more warmer temperatures into our environments than you are used to. Next slide, please. And we've brought some evaluations that were done in this study, where we've studied three case studies with three different envelopes that are usually adopted here in residential buildings, and using a human thermal regulation model to understand the difference between simulations using climate data and simulations using projections of the climate. So in the next slide, please. So we've tried to understand the behavior of these case studies using as a reference these four different indexes. And in this last slide, this is the last slide that we've brought to show to you today. It shows the results of this evaluation that showed us that actually we have to make some adjustments in all the studies we proceed, and that will be used to adjust our regulations and try to make these evaluations using this future climate, because here, for example, we can see the big differences in these indexes when we use the history of our climate until now, and when we use these projections of future climate, as I said. So we can see here the differences in these 3 case studies between these 2 different climates, like Brasilia, here where I am, has a very mild climate right now, and Manaus, which is a very hot and humid climate, and how it's going to be in the future by 2050. So this is something that highlights the importance of making these studies to make the design of the buildings considering this climate change that we are going to face. So I think that's it. And I thank you very much. And we are here to discuss with you later.
That was a very interesting presentation, Alexandra. Thank you for that. Are there any questions? Vincenzo.
Yeah, thank you for your very interesting presentation. I have a question about the performance assessment of buildings, and specifically as regards the ventilation, natural ventilation, airflow rates. Do you consider ventilation airflow rates based on indoor air quality requirements, or you also take into consideration ventilative cooling strategies in the values of airflow rates in the calculations of performance of buildings?
Perhaps I can help Alexandra. We do natural ventilation airflow network simulation in Energy Plus. So it's natural ventilation based on temperatures. Does this respond to your question, Vicente?
Yes, so you mean that in case a ventilative cooling strategy can be implemented, you take into account it based on the values of the indoor and the outdoor temperature, if I understand well.
Yeah. So normally in the south here, we allow indoor temperatures between 18 and 26. So if the temperature is okay, we ventilate it.
Okay, thanks.
Karin?
Yes, when you compare the 3 construction systems, I wonder if I was surprised you compare the systems globally and not maybe parts of the system which contribute the more to comfort, like the ceilings. Roofs or?
Well, the roofs are different with the system. So normally with the brick system, you'll have clay tiles. With the concrete system, you will have asbestos cement roof, and with the steel frame, also normally asbestos cement roof. But I have to tell you that it's when we evaluate bedrooms, the insulation of the roof is not always good because it doesn't allow you to lose heat during the night.
Yes, I understand. Well, what I wanted to understand is if part of one system can be implemented in another system to make it better.
Oh, we haven't done into this in this work, but yes, you can mix systems. Yes. But what was surprising on this evaluation was that the core temperatures start rising substantially, mainly in Manaus, as you've seen in the graphs there that Alexandra presented to you, and we are reaching not dangers, but caution levels.
Richard.
Thank you. A question just regarding the temperature. Do you see that your thermal gain is solar based in terms of coming through windows, or is it radiant heat coming through the building fabric?
Both, yes. The windows are small because it's a low-cost house. So then you get mainly through the rest of the envelope.
Okay, interesting.
Any other questions? No. Sally.
Yes, I wanted to ask with regard to the target temperatures. Two questions really. One, is there any variation between daytime and overnight temperatures that you allow? And also the second question is, can you conceive, is there any idea that there will be any targets above that 30 degrees? There will be any allowable temperatures in the future above 30 degrees?
Well, the temperature is the same day and night, the limits that we used. We use the 30 degrees because it's more or less the limit of the adaptive thermal comfort model. But people are used to higher temperatures here.
Yes.
So we need more work to understand perhaps the limits that will be able to survive,
Yeah.
And people that will most suffer will be people in slums. So that's very basic construction.
No, that's really good. Thank you very much.
Thank you, Roberto. Thank you, Alexandra. If you could send me your presentation, I will include it in our website. Thanks. Next up is Louis.
Yes, I'm going to share the screen. Is that okay?
Yeah.
So I will talk to you about with my colleague Karine on summer comfort regulations for new buildings in France, and Karine will talk about existing buildings. So we have this new regulation since 2020-22 in France, first for residential buildings and then for office and educational buildings. And after 3 years of work and simulations, we will have very soon, in 2 days, the regulations for all other buildings types you can see to the right. But we don't have the final text for the moment. So what is the metric we use for overheating for new buildings? First, our regulatory verification is based on simulation only during the design phase. We don't have measures like every country, I think. We use the number of degree hours of discomfort. So I will explain it to you after. It's a calculation for the whole year. We add all these degree hours of discomfort for hot periods, but only for the hours when the building is occupied. We consider the entire building, and we have 2 zones for only for collective residential buildings, with a crossing and a non-crossing zones regarding to the openings and the air, the natural ventilation. And our metric is based on comfort only, not on health. So what are these degree hours? It's the difference between indoor operating temperature and an adaptive comfort temperature. Excuse me. So every hour we test if the situation is comfortable or not, and whenever the operating temperature exceeds the comfort threshold, we record the excess in our DH meter. So our limit for comfort is adaptive only for days. It's between 26 and 28 degrees. And the night we don't have the adaptive comfort. We put the limit on 26 degrees. So each time we exceed the comfort, we add the temperature exceeds, and then we by adding up the degree hours for each day, we get the annual degree hours. And then this annual total of DH is compared with our two regulatory thresholds. 350 degree hours and 1250 degree hours. If your total is below 350, the building is expected to be comfortable during hot weather. If your total is above 1250, the building does not comply with regulations, and you must review the design before starting the construction. And if you fall between the two, it's the yellow zone here, the software will calculate a virtual cooling charge, a potential air conditioning consumption penalty, which will be added to our energy consumption indicator. So this will therefore penalize you in terms of compliance with consumption threshold. This is because we assume that the user may eventually install air conditioning in the building at a later date. This consumption penalty is proportional to the amount by which the 350 degree hours are exceeded. And when we, yes, I didn't say that. When we calculate the DH indicator, we consider that the air conditioning is turned off if we have air conditioning in the building. You have to respect the thresholds without air conditioning. How is the climate for us? We have a temperate climate in France, and we have 8 climate zones. And we use for the simulation a heat wave dataset covering a summer period for us from mid-July to end of August, with extreme temperature for France, not the same as Brazil, between 1 and the 1st and the 15th August. It's a climate field that correspond to our first severe heat wave in 2003. Maybe it will be worse in the future. We don't know, but we have this hot period in our field. And the software considers that people will manage movable sunshades and opening windows regarding to the system that is set up, if it's manually or automatically. If you have an automatic system, it will be better for the results on DH, on degree hours. We have a few prescriptive measures too on maximum solar factors for windows. That depends from the orientation. We ask to have a window that must be able to open to at least 30% of the area, and we ask to cut to have an automatic door when you have a cooled area, but this is more for offices and not for residential buildings. So we make these simulations on official software, and during the simulations, the air conditioning is turned off, and but the temperature simulation takes into account all the passive or semi-active systems that are installed in the building. So we have this is new for us because for the last regulations we had before the RE 2020, these systems were not taken into account. So taken into account. So we have this system. We can value we can use it now to reduce the degree hours, such as Canadian well or external automatic shadings or geocooling, yes, and so on. So now, Karine, if you want to explain on existing buildings.
Yes, I will talk about the regulation for existing buildings, which is less modern than the part presented by Louis, because also in France, we always start by regulating new buildings, and then we work on existing buildings. For example, our regulation on global renovation is the method of our last before our last regulation for new buildings. So for existing buildings, we have several regulations. We have the energy performance certificate, which is, I think, European. There are equivalents in Europe. It's an obligation to display performance when you are selling or renting a property. And this regulation briefly points out the summary-related attributes of performance, just you have or you don't have this or this attribute, and then you have points. There is a thermal regulation for existing building, which has two modes of application. One is global, when there is renovation of a property, which is a large property with a cost which is 55% of the building's value, and for buildings constructed after 1948, the period in France when the construction became more industrial. And then there are several obligations that I will come into more details later, but there is something global and also requirements of means. And there's also a regulation element by element. When an owner decides to change or to install an element, he must comply with a minimum performance level. So it's a requirement of means on each element you touch. And there is also a decree for works carried out. It's an obligation to implement thermal insulation when you are carrying out works on envelopes, such as facade renovation or roof refurbishment. So you don't redo a roof without adding the proper insulation to it. And also, I have to say, these regulations are really aimed at first at winter performance, but the obligations related to winter performance, such as mandatory insulation of roofs, for example, it's part of summer efficacy. It makes part of the result for summer. Next slide. So the global existing thermal regulation for a project on a large building. The aim is to limit discomfort and to limit the use of air conditioning. So you have to ensure an acceptable summer comfort. Conventional indoor temperature in summer must be below a reference temperature. The calculation of the temperature reached by the building is conventional. It's a calculation with the method, and this temperature must be below the reference temperature, which is the result of the same mode of calculation for a building, for the same building, but correctly protected. So correctly protected in terms of solar factor. There are also obligations of means. For rooms intended for sleeping, solar factor of openings must be below a reference. And new openings must be able to open over 30% of the surface. It's partly the same obligations of means as in the new buildings regulation. And there are specific obligations related to cooling. If you choose to cool the building, there is a requirement on energy. There is a reference consumption which is calculated with the reference solar factors. And when you equip the equipment of a cooling system, it must aim to maintain the indoor temperature at 26 degrees Celsius, but not less. And the same when the building is in use, we are not supposed to choose an indoor temperature below 26 degrees. Of course, there's regulations. I must say that it's very easy to control new buildings regulations, because you have procedure for new buildings. For existing buildings, there are less means of control. So it's a regulation which is less applied, and the summer part of these regulations are less familiar to professionals. So, well, it's on the paper, or it's written like that, but it's not globally done like that. And of course, for the temperature of use of cooling system, it's evident that nobody controls if you are air conditioned at 26 or not. Next slide. The existing thermal regulation element by element. The obligation is mainly on solar factors. The solar roof windows must be really protected. Very good level of protection. And in case you install a cooling system, all equipments must be upgraded for solar protection. The exception is for urban planning rules. In France, we have a lot of old buildings and a very strong defense of the architectural style of old buildings. So it's not always evident to put the proper protections. Next slide. Thank you. And the energy performance certificate, it's the obligation of showing the efficiency level when you sell property. There's a list of dwelling characteristics. It's only for residential, this one, for the moment, for the summer question. There's a list of dwellings characteristics that favor summer comfort. So you check if you have or you don't have these characteristics. And then you have a level, I think, on a 3-level scale. So it's very simple, but it talks of key elements of summer protection. Well, so this is all for our continental, our temperate climate. We have also regulations for tropical climate, and what has been said about Brazil is very interesting, because we are in those kinds of questions. For example, for the continental climate, if we reinforce the energy performance certificate for the summer comfort, it may lead to it may induce reaction with air conditioning that not to show an insufficient performance. And for tropical climate, there are also questions about improving the building for passive situation, or to improve it for air conditioned situation. Thank you.
Thank you, Karin. It was very interesting again. I noticed that there is before going to you, Sebastian, there is a question from Richard. Oh, before going there, I didn't realize that the Earth Tube is a Canadian well. Interesting. Rob, Richard asks, how do you account for humidity when using ground source cooling?
We don't, I think. I'm not sure.
Humidity?
Yes.
For ground cooling, I don't think we
don't.
No.
For the moment, we don't. We don't. In fact, we would have to redo the map of the climate regions for summer, because it was done mostly for winter. There are consideration about solar reception, but not more. And yes, there are parts of France where humidity may be a problem sometimes in summer, but we don't have climate modelizations that talk about this humidity in our regulation, and we don't have this. We really don't have it for the future. There's no modelization of humidity for the future.
Okay.
In France.
Thank you, Karine. Sébastien?
Yeah, thank you. That was a very interesting presentation. I have, I guess, a couple of questions. The first one is so you use degree hours, and is the degree hours that you use to assess like buildings the same for all climates across France? So like in the north, it's cooler, and in the south it's warmer, but do you use one, like I think it was 350 and maybe 1,200 or something, the thresholds, are those numbers the same everywhere in France? That's my first question. And also do you have something that's more, because that's for the whole cooling season, do you have something that's more specific, like a metric that is more short period for, let's say, like a peak temperature or something like that you look at as well in your code? And for residential buildings, do you have a standardized schedules, because you look at the degree hours of occupied time, I think your presentation said. So do you have a standardized schedule for residential buildings, or is it dependent on the building? Because to me, like when I'm looking at this right now, I'm working with codes, I'm assuming there's always going to be somebody in the house, because you never know what the house is going to be like. Like you don't know if it's going to be elderly people, but I don't know. Anyways, those are my questions. Sorry, lots of questions.
Oh, the first one was
the degree hours,
350,
like
the 350. Maybe I can
yeah.
tell it. 250. It's considered for like a level which makes that people may want to have air conditioning. So it's the same everywhere in France. In fact, it's not the same. The climate is different, but the people are the same. Maybe people in France are very. They move from the south to the north. You can have different. You don't have in the south only people that are experienced in the south. So we have the same level, but this is the first level of really which says the building is comfortable, but the higher level, which makes that the building is or is not mandatory to all right with the regulation, is not the same in the south and in the north, because in the south it's considered possible to have air conditioning, and it's considered in some situation normal not to be able to not to be able to respect the 1,250 degree hour.
Okay.
For example, in situations where you have traffic, a lot of traffic and noise, so it's considered that the windows will be closed at night. So you won't be able to. It's normal not to be able to be below the level.
Right.
And then we just look to the whole cooling season. We didn't have a peak indicator.
Yeah.
And for the schedules, we have different occupation schedules for depending from the type of the buildings. But yes, I agree. Since 2020, we have a lot of people that are present that are in their dwelling during the day and during the week, but we consider that they are not there before 5 after
5 or 6.
Yes, 5 or 6.
Well, in fact, they're on the weekends. They are supposed to be
And
here,
yes, on weekends
and
and
on Wednesday afternoon. So we have 2 complete days and 1 afternoon, and 3 days with no. So it insists more on night comfort than day.
Okay, thank you.
Thank you, Vincenzo.
Yeah, thank you very much for your presentation. Looking at your presentation, it seems that emphasis is given to windows, mechanical systems. I wonder about the opaque components. Solutions such as cool roofs or high inertia or vented walls or green facades, are they fostered or considered in your codes?
Well, in fact, in France, we need a great amount of insulation for the winter season. So, as regards that, we have this insulation. In fact, the cool roof, the albedo, the green solutions will be less efficient when the winter insulation is at the right level. That's why we insist on solar factors. Louis?
And for the calculation, we don't have we don't take into account the heat island effect. The heat island effect. I forgot to say that, and we don't have a modelization for green roofs or green facades, but industrial companies can ask for a special model if they want. They can ask the government to implement to put into the software a new model if it's needed, but you have to pay. So if you have yes.
Thank you.
Thank you, Victoria.
Hello. Thank you. That was a really interesting presentation. I've heard about the amazing work France is doing in this area, but this is the first time I've actually got to understand it properly. I was just wondering how easy the comfort assessment is to pass if you're using such an extreme weather file from a heat wave, compared to, for example, using a design summer year 1 weather file. We're actually in the process of kind of understanding which weather files to use in our methodology, because depending on which weather file we select will be a big influence on how many buildings pass or fail in New Zealand. So yeah, is it easy to pass even though you're using such an extreme weather file or heat wave scenario?
For the existing buildings, it's you've seen the regulation is relative. It's you compare your building to a building which would be more protected. So the choose of the climate file is a bit less important, but yes, it would be better if we used climate file of the future. And in fact, it all would be better if we use the climate files for the new buildings or existing buildings of the future, and with the heat urban heat effect included. And I believe in a few years we will manage to do it. I don't know if it's 5 years, then I don't know, but
we have for new buildings we have a national database since the beginning, since 2022, and here you have the result for the different climate zones. Yes, it's very different from one zone to the other. Here in Nantes and Brittany, we have the central H2A. It's very easy to manage the threshold, but in other zones like where Karin is, in H3, we currently are close to the limit often. And but when we build the regulations in France, we do a lot of simulations with different buildings and different parameters to be sure that it will be affordable and technically and economically. So the thresholds are fixed with a lot of simulation before becoming a regulation. But we have sometimes surprises. Yes.
Roberto, thank you. Roberto.
Well, thank you for the presentation. I have a question. Your regulation in the past was mainly directed to heating. So insulation was really increased substantially, double glazing, roof insulation, wall insulation, and all that. And we know that for summer, it's not like that. So what are your thoughts on what's going to happen with all these houses that have been kind of passive house design from the past, how they are going to behave in the future? People are jumping to air conditioning substantially these days, or are they adapting their behavior and trying to bring shades to the buildings and this kind of things? Because I think you'll have a heavy increase on cooling systems and on the electricity grid, isn't it?
Well, we have studied these considerations a few years ago, trying to see if what we decided for new buildings would be a problem for the summer. We also studied a panel of houses which have been on dwellings which have been ameliorated for winter, and the owners of the occupants globally find that the summer comfort is much improved with the insulation which has been done. So this is positive. And also, this summer we will work for our government on a study which to clarify if insulation is a problem or not for the summer season, because a lot has been said about it, but not always very serious scientifically. So we have a work in progress about that. And also, we know that insulated buildings are a problem if you can't open them. So the real question is, can we learn to open? Can we be organized to open? Because there's a problem with insulation, but there's also a problem with the lack of security about the windows.
Thank you.
Thank you both. I think there is a question from Michael. Michael, can you pose your question?
Sure. Thank you. It's just the question was around the length of time it takes to do the simulation for overheating, and if you're noticing if there's an increase in time, if it's getting quicker to do, especially with the advent of machine readable files and the use of artificial intelligence.
I don't think it's very long. It's very quick, I think, in our software, but it's not. Je sais pas, Karine, que non, je crois pas que ça prenne du temps, les simulations.
La durée d'une STD?
But
Une simulation.
Yes, the time to make the summer simulation, yes. I don't think it's very long.
C'est compris dans le. It's included in the
software. Yes. Ouais.
Long. Well, summer modelization and simulation. It means you will use software which is quite sophisticated generally. And that's the problem. It's difficult to have a calculation which is really interesting for summer if it's not sophisticated. But I think it's quick, but it's not affordable for every. It's made by engineers.
Is it the same software that is used to predict energy consumption?
Yes.
Yes.
Okay.
We have
the same.
Okay.
It's make at the same time, and
okay, so that saves time. Yeah.
That doesn't take time.
I'll turn it back to you, Michael. What do you guys use for simulation? Does it take time?
It does. So for the energy modeling for residential buildings, the most common software is called NatHas, and that is usually a day or so at the moment of inputting building plans, getting all information about insulation levels and windows, and then doing work to optimize the design. There's and for more, for larger, more commercial buildings, it's more complicated, and the energy models that are used for that are can take a number of days to complete for a large commercial building. But there is a growing trend to use machine readable files and the use of AI to produce outputs, which then need to be, at the moment they need to be checked. But I think there's a possibility that things are going to be speeding up in energy modeling.
In France,
we
are interested in the same. I think in the same things. In our we have tried to do in advance thousands of modelizations to offer a simplified system that can be used by property owners to calculate the degree easily without sophisticated software. And there's another public organization in France which tries to use IA to make this kind of model, also to be able to predict summer efficiency with a few a light description of a dwelling.
So if I understand well, you use archetypes for different
not archetypes. No. You describe your dwelling. You describe the essential elements of your dwelling, and we give you the result that would have been produced by the simulation with the same description for dwelling a basic model for the considerations that are not very interesting for the summer comfort. You just have to explain the elements that will really be important for the calculation of the summer comfort, and for the rest, the system doesn't need information. So the number of information needed is small.
But it's
So
for
how-
our it's our software that we have developed, not for the regulations. Yes.
Okay. And so the thousands of simulations that you did to generate that database from which the owner can put information, that I assume was based on archetypes, or did you use an example of all the buildings in France? How did you generate?
No. It's very difficult to do it, because if we want if we want to embrace all the kinds of buildings, it would be too much, and we couldn't make a simple model. So we worked on a collective dwellings, and this made the question quite simple. But for individual housing, it's much more intricate.
Okay. I have one question before going on to Michael. Another one. You mentioned that you have windows for different sides of the house specifically. Do you have any understanding or knowledge or collect data whether the installers put the right window on the right side of the building?
I'm not sure. Sometimes they they mix the installation. Yes.
Yeah. Okay.
I don't know.
I would suspect that would be somewhat of a
You have to
problem.
be vigilant on the construction. Yes.
Yeah. Thank you both very much for the presentation. We go next to Michael.
Thank you, Melly. Share my screen. Presenting mode. So we could. Great. Hopefully you can see that now.
Yes.
Great. So I'll be doing a double act of Massan from the CSIRO. I'll talk through what is actually in the Australian Building Code regulations, which is relevant for overheating, which covers buildings for residential, commercial, and community for new building, and also for building undergoes a major renovation. Usually, if the floor area is increased by 50% or 50% of the volume of the building is affected, then the entire building has to be brought up to the new level. And then I'll hand over to Massan, and she'll talk about the research she's doing into developing overheating modes, overheating metrics that can be used in building codes in Australia and potentially overseas as well. So high level in our building code, this is current regulation. There's what we call a functional statement. So H6F1 relates to residential buildings, and it says that a building must improve occupant health by mitigating the impact of extreme heat and cold, and when there is an energy blackout, so if there is no power to the house. And so that's just talking about the passive elements of the house, insulation in walls, performance of windows, and orientation and the like. It's a general principle that's there in the building code, which then the other regulations try to meet. And then for residential, for commercial and community buildings or public buildings, again, there's some similar wording, which is about maintenance of comfort, really, maintenance of acceptable internal conditions when the building is occupied. So this is an overview of the residential building requirements. So I guess up front, I should say there is no overheating requirement within the Australian Building Code. There's no requirement for the building to be to not overheat. All of these measures I'm talking about are within the energy efficiency requirements, and really energy efficiency requirements to reduce greenhouse gas emissions and reduce energy costs for occupants is used as a proxy for preventing overheating. Australia has 8 climate zones, just like France, which Masan will go into in a little bit more in her presentation about where they are in the country. And you have a differential requirement depending on which climate zone you're in, which is, I think, it's a very common approach. Australia has a wide range of climates from tropical to alpine, with everything in between, from hot desert climates to humid climates. So there's a great range in our building code as to respond to all of those climates. For residential buildings, when we're talking about either the modelings that a model that is used to predict how much energy a house will be and what temperature it will be, we've used past climate files. So these were updated recently to take into account the most recent few years, but there's still a backward-looking climate file and weather file that was used to both develop the provisions and what's used in our energy modelling process. Within the code, it's very standard. There are 2 pathways that people use for houses and for apartment buildings. One is the elemental, so setting minimum standards for insulation for windows, both for window U value, wind-solar heat gain coefficient, setting minimum standards for building ceiling. There is a prescriptive requirement for ceiling fans to be in place in warmer climates, so all new homes have to have ceiling fans in place. But the most common pathway that people use to demonstrate compliance with their minimum standards is a whole of home energy benchmark, which I was talking about before, which is operated by the CSIRO and software, which produces a whole of home energy benchmark using a star rating system that is based on predicting what the heating and cooling loads will be, and then what how much energy will be used, assuming an average efficiency to heat or cool that dwelling, that house or apartment. There are 3 thresholds you need to meet. There is an annual energy consumption, but there are separate winter winter heating loads and summer cooling loads that you also have to meet within your energy model. So you can't have a home which performs very, very well in the summertime, but not very well in the wintertime. So they have to be balanced across the 3. It's a very similar approach for our multi-residential apartment buildings, with the exception that there is an additional whole of apartment building energy model that you can do, where you model each apartment as heating as zones, and ensure that the predicted heating loads and cooling loads are better than a reference building. In commercial buildings, again, there is no specific overheating requirement, and energy efficiency is used as a proxy for overheating. Minimum standards for the elemental for building fabric is similar for residential, but there are more prescriptive requirements required around the air conditioning system used in the building. So above a certain size, a building is required to have a night purge facility, so it can eject hot air from that building when the building is not in operation overnight. Economy cycles that draw in cooler fresh air are mandatory, but that's more of an energy efficiency requirement. And the more sophisticated your building, the more sophisticated the heating and ventilation and air conditioning controls are required to be. Most of the commercial and public buildings in Australia will be cooling dominated, so that most of their energy will be used for cooling. And partly because of that, most of our commercial and public buildings are required to have light coloured roofs as standard. The provisions for commercial buildings have just been updated. In fact, they'll be made available for use here in Australia in 2 days' time on the 1st of May. They won't become mandatory until the 1st of May in 2027. But these new provisions were developed using a future average climate file. So representative concentrated pathway, I think is what RCP stands for, of 8.5. 2050 was used to develop our provisions as they will become the minimums going forward. In the commercial building space, if you can use an energy modeled pathway to demonstrate your compliance with the minimum standard. So it's a whole of building pathway. But if you do an energy model since 2022, you've had to show that the building will meet certain comfort standards. So in 2019, we introduced a requirement to use predicted mean vote of plus or minus 1. So if you're familiar with predicted mean vote, it is a predictive measure based on the metabolic rate of the occupants of a building, what you assume their clothing level to be, the air speeds, the radiant temperature, humidity, and it's on, would you predict that someone will be comfortable within that space? But in 2025, there are other methods of demonstrating that the building will stay within comfort. A dry bulb temperature of 21 to 24 degrees is one measure, so a relatively narrow band in comparison to some of the bands we've been talking about previously. Or you can use a reference approach where you look at the peak cooling loads and the peak heating loads and make sure that your proposed building is going to perform better than a reference building, which is based on the elemental minimum standards within the code. So just before I hand over to my son, we've done some research recently where we looked at the new commercial building 2025 building envelope, building fabric provisions, and looked at what would happen to the internal temperatures if you turn the air conditioning off. So is the building protecting its occupants outside of there being air conditioning present? And the answer is it's no. It's that you can see, so the external temperature is the red line there. When you have air conditioning running, you have a very stable temperature. So yeah, the indoor operative temperature within HVAC is operational, is fine, as you would expect. But as soon as there is a temperature blackout, and this was a hospital ward that was modeled, then you see that you get some very, very uncomfortable temperatures. The file this was based on was a past heatwave file. So this is for Melbourne, which is one of our larger southern cities. It has a very big diurnal range. So in the wintertime, it gets temperatures below 0 overnight, but in the summertime, it has temperatures above 40 degrees. So it's a very dry heat. And this modeled a 7-day heat wave. And as you can see, all of the zones within the building became very uncomfortable by the 4th or 5th day. Okay, so I'll pass on over to my son now for you, if you're ready to take over.
Yes, thank you. Thanks, Michael. Before I start, please excuse my rough voice tonight. I had my flu vaccine, and this is the symptom after the vaccine. So as Michael mentioned, CSIRO is leading a research to develop residential overheating model for Australia. And the objective of the project was to first review the existing international standards and national building codes, then to identify gaps and limitations in current guidelines, and finally to develop residential overheating model for Australia to be included in the code. Next slide, please. In 2023, we conducted an extensive literature review and we reviewed all the existing international standards and national building codes. This is a journal paper that we published in 2024, and the aim of the paper was to identify the gaps and provide suggestions for improvements. So as you can see in the table in the right side, we have reviewed all the different standards which are existing in the literature. And then in each standard, we looked at the metrics that have been used. Also, we looked at the indices that have been used in these standards. Also, we identified the threshold limit that each standard has, and also the thermal comfort model, for example, if the model is a static model or adaptive model. And we looked on the building type and building operating system. Next slide, please. We also looked at the national building codes, all those countries that are already including the overheating and thermal comfort standard in their building code. For example, Belgium, Germany, France, UK, Netherlands, and all the other countries. So first of all, we looked at the standard that have been used in these countries, and then the indices that they have used, the threshold limit, the thermal comfort parameters, which was included in the building code, and also if the code is sensitive to occupants' adaptive response or not, and what are the building types and building operation system. Next slide, please. So this paper is published, and you can have access to it online. If you are interested, I can give you the details about that. So the key lessons that we have learned from the literature review, based on the lessons, we have developed our overheating model and criteria based on 3 scopes. So first of the model is adaptive model, which is sensitive to climate and also sensitive to occupants' adaptive behavior. The index that we are using is SET star, which includes 6 parameters, 4 environmental parameters, including air temperature, mean radiant temperature, relative humidity, and indoor air speed. And also it includes 2 personal parameters, namely clothing value and metabolic rate. And the metric that we are using is degree hours. This is very similar to France, what Louis presented. We are using the sigma degree hours, which quantifies intensity and duration of exposure to heat stress. Next slide, please. As the national project, we collaborated with 5 Australian universities, and each university was responsible to collect measurement data and conduct a field study for us in 1 or 2 Australian climate zones. We managed to collect the data for 7 Australian climate zones. As you can see from the map, Australia is a vast country with diverse climate. It starts from the climate zone 1 up in north in Darwin and goes all the way down to climate zone 6, which is Melbourne, and climate zone 7, which is Canberra, where Michael is based in. So these 5 universities were University of Sydney, University of Adelaide, Monash University, Griffith University, and University of Wollongong. Next slide, please. So according to thermal comfort concept, there are 6 parameters which has impact on human thermal regulation, 4 of which are environmental parameters, and then 2 personal parameters, including metabolic rate and clothing value. In the existing building codes and regulations, mostly the index that has been used was operative temperature, which is a combination of air temperature and mean radiant temperature. And 2 other parameters that have been overlooked, like humidity and air speed. And that could be because measuring airspeed is very complicated. It's actually one of the most complicated parameters in the IEQ studies. So for us, we decided to measure all of these 4 environmental parameters in our study. Next slide, please. So this was the solution that we had for airspeed and mean radiant temperature. First of all, we assembled our globe temperature measurement, as you can see in the right side. That's basically a ping pong ball that we colored it in dark and black color, and we connected it into a probe. Then the probe is connected to the data logger. We also have the anemometer to measure the indoor air speed, and we connected each of these to 2 data loggers, and the data logger also can measure air temperature and humidity. So with these 2 sets of data loggers, we covered the measurement of 4 environmental parameters. Next slide, please. So as you can see, this is a photo of one of the studies that we did, and we published a paper on that in 2025. So 2 sets of data loggers were installed in each home, and one set in the living room and one set in the bedrooms. I think this slide can answer one of the questions that was in Melly's email about if the metric, which zones are included in the metric. So for us, we are looking at 2 zones, living room and also the bedroom. And next slide, please. And parallel to measuring the environmental parameters, we also had the thermal comfort survey. We managed to have the unified questionnaire across all climate zones. And the survey had 11 questions. We asked about the thermal sensation vote and the acceptability vote. Also, another question was about the thermal preferences, but you like to be warmer, colder, or no change. And also, we had questions about the occupants' clothing value. As you can see in the graph, the occupants could identify their clothing value. Then the other question was about the metabolic rate, if they were sitting or walking or talking. So based on their activity, we could predict the metabolic rate. And also we had questions about the occupants' adaptive response. When they feel warm, what do? They open their window, using the ceiling fan, using the shading or blind. So all of these adaptive behaviors were recorded. So we had all of these informations and data in terms of the environmental data and thermal comfort surveys. And with all of these data, we were able to calculate our SAT star. Next slide, please. So this is the model that we developed. First, we calculate SAT star, and then if you look at the model, the x-axis shows the mean monthly outdoor air temperature. So if someone wants to calculate and understand what's their upper limit of acceptability overheating, they need to first calculate mean monthly outdoor air temperature, and then the model which shows the upper limits of overheating, the threshold of overheating. We also developed this regression model and regression equation. So if you put your mean monthly outdoor air temperature into the equation, it gives you the upper limit of the overheating threshold. Although the aim of the study was to develop the overheating threshold, we also looked at the lower limit of acceptability, which could be used for the cold seasons and in the cold climate for the lower limit of thermal acceptability. So I'm also conscious of time, so I stop my presentation here, but I'm happy to take questions if you have some more questions about the details of the project. And also it's good to mention that because one of the questions in Melly's emails was about that is the metric based on comfort or health. As you could see in this current model, the metric and the index is based on overheating or comfort, but we are extending the project to assess the impact of health on and the heat stress on health. So this is the extension of this project that we are looking at the health impacts as well. So it would be our future project. Thank you. Back to you, Michael.
I think, if we have time, we'd be happy to talk through questions.
Yeah, of course. Okay. So before going there, though, I'd like to mention that we have a small change, and the fact that we are going to probably overshoot our 2-hour meeting. We are going to continue primarily because Sally cannot make it to our next meeting, and we want definitely to hear what she has to say. Those that have to drop off can consult. I'll put the recording online. So we will take the time that we need. Roberto.
Well, thank you very much for this very interesting presentation. I have a question regarding, the different approach between the what you showed in terms of comfort and your regulation at the moment that takes into account cooling and heating load. Because when you go to naturally operated buildings, reducing the heat load does not give you proper comfort sometimes. So I've seen some discussions in Australia in the past. I think Terry Williamson was one of the persons that discussed that. And if you have a very nicely adapted house in terms of bioclimatic adaptation, it will not behave very well in terms of the load. So how do you deal with these houses?
Yeah, exactly. Well, thank you for raising this. This is a very interesting question. Well, first of all, for these criteria and overheating criteria, we are only looking for the free-running buildings, like those ones that are using the natural ventilation or only ceiling fans, not air conditioning and not heating. So the criteria would be for free-running buildings. But then you are right. So in Australia, if you want to be more climate adaptive and more sustainable, then it wouldn't have that much good impact on the cooling and heating load. So this is the reason that we decided to develop this overheating model. To maybe this model could help with that question in hand.
Thank you.
And but just maybe to add to that from a regulation perspective, so the existing regulation has elements which you could say do try to prevent overheating, but I think going forward there's a very good case to make to keep them separate. So you have energy efficiency regulations which are designed to keep energy bills down, to reduce greenhouse gas emissions and energy grid. But I think that the measures that you're looking at, especially for residential buildings, should be a separate measure and have a separate mechanism for compliance.
Excellent. Any other questions? Thank you, Michael. Thank you, Marzan. It was very interesting and informative. I have to apologize to Tristan and Ryan because I'm pushing them to our next meeting. And probably the way that we are going, we're probably going to have a third meeting, which is excellent. So, Sally, please go ahead with your presentation.
Okay, so the first question is, can you see my my screen?
We can.
Excellent. I'm not going to risk any problems by attempting to go into display mode. So this is the version you'll take. And I also have to point out as well, this is as you can see from the date, this is a previously prepared overheating presentation. It is relevant, the fact that this was previously prepared, because the overheating standards that we use were introduced in 2021, and they are currently the subject of quite a lot of political pressure, because there is seen to be a conflict between a number of regulations, in particular overheating standards, and our current government's focus on economic growth. So this presentation was prepared for presenting to a group of volume house builders within the UK. So I'll be adapting it as I go along. Yes, again, just to look at what this is going to do, we've got a bit of background about the legislation, the routes to compliance, some of the literature behind climate change, and then looking at the very interim results we've got of the impact of Part K on what effect we're seeing on the built environment for new buildings. So to leap straight in, there was an amendment in 2021 to the building regulations that apply to England and Wales. That was it. We put in what's known as Part O, overheating. And that's that for new buildings, reasonable provision must be made to limit unwanted solar gains and to provide an adequate means to remove heat from the indoor environment. Those section 2, the fact that in meeting those obligations, you have to take regard to the safety of occupants, those do have relevance for some of the internal to the UK complaints we've had from volume house builders. So we are within the building safety regulator, we are responsible for providing guidance that allows people to comply with these regulations. And guidance was developed that provided 2 main routes to complying with these regulations. These are known as this was supposed to be an easy to follow flowchart, but the 2 routes to compliance are known as the simplified method and the dynamic method. And they are quite different in that the simplified method is designed to ensure that elements of your building are in place. Those are mainly focused around limiting solar gain through glazing. So they limit the amount of glazing you can have, particularly on the south and west facades. And they also look at your ability to purge your dwelling of heat, particularly overnight. And so that looks at openings. Again, that tends to focus on openings and glazings, openings within your bedroom area. Although this is presented as a flowchart and it's got 2 different colors there, it's got the orange for high risk areas, which are, by high risk we mean actually London, because that's the way our temperature zones work, and medium risk is everywhere else. The requirements we actually have although they're listed there as physical requirements, they are exceptionally difficult for buildings to actually to comply with. So in practice, it is quite rare for buildings in high-risk areas to be able to comply with those requirements. The other route that we have is known as the dynamic method, and for this that requires essentially the dynamic simulation model. So that we would have to be presented with to be allowed to build a building, you have to present the results of a dynamic simulation model that can include all sorts of things beyond just glazing and openings. The dynamic simulation model is directly taken from the Technical Memorandum 59, TM59, that is produced by CIBSE, the Chartered Institute of Building Service Engineers. That's what it's taken from. So it uses both all the criteria within TM59, and also it uses the metrics for overheating are included within TM59. And the metric for overheating that is there's a metric for daytime overheating, but that's rarely an issue. The main one that's an issue for compliance is that for bedrooms, you are required to have the model is required to demonstrate that less than 1% of the overnight hours, the temperature in the bedroom will exceed 26 degrees centigrade. In reality, that's the most difficult for buildings to comply with. Then I've got just looking at again, this was prepared for some of the major house builders. So it's just looking at what the background to overheating is. There's that, just as a note on that, the excess deaths in summer 2022, the ONS, the Office of National Statistics in the UK, has just started releasing they've now released information about where those excess deaths occurred, because there was a presumption previously that most of them were in hospitals or care homes with vulnerable people. Actually, half of those excess deaths in summer relate to occur within private homes, and some of the predictions related to the rise in the climate change that is happening faster than was anticipated in the UK is that those excess deaths, which were approximately 3,000 in 2022, could be up to 10,000 by 2050. And I was also, again, because I was talking to house builders who were talking about the fact that there are clear physical links between a rise in temperature and the relative risk of stroke, although obviously not all of those excess deaths were due to strokes. Then we're looking at what the impact on existing housing could be, and that's roughly what this chart looks at, which is it's looking at what you would have to do to the existing building stock if there is a rise in, to avoid overheating, if there is a rise in, if there is a change in the climate. So as you can see, even with the existing climate, we're looking to have a number of obviously the green is that you don't have to do anything to the buildings, so and there's a rising scale of things that you'd have to do to existing buildings. So you can see that with a higher rate of climate change, all buildings will have to have very extreme measures installed in them to avoid overheating. Then just having a look at what are the predicted changes in temperatures. So we have the TRY refers to typical reference year. So it's not the design summer year, but it's they're related to each other. So this is looking at the cooling degree days based on the current typical reference year that's used for building design, and we've just got a revised set of reference years that have been published, and the results are for the predicted future. I think the technical term is it's horrific. It's fine for me. I'm in London at the minute, but I'm actually based in Edinburgh. So as you can see, Edinburgh and Glasgow are fine, but in London it's going to be bad. It's bad now, and it's going to get worse in the current future years. This slide then goes, apologies for the fact this rather jumps around in its narrative. I was then having a look at this is looking at what the impact has been of the introduction of the building regulations that came in 2021 and were in place.
Did we lose Sally?
Yeah, she's frozen for me too.
Oops.
Looks like we've lost her.
Yeah, I'm sending her an email. Hopefully the email works. That's unfortunate. Maybe she will log out on again. In the meantime, for those that are presented, thank you, Louis, for sending me the presentation. If Roberto and Michael could send their presentations, that would be great.
Just while we're here, I just want to say many thanks to CSIRO for their support with New Zealand's research. Dr. Masan, you and Richard Didier very much forefront, and we're very appreciative of the way that you have been able to share your research with us and to assist us with our proposals, which Victoria will be presenting next time. It's an interesting space. We are in the space where we want to get regulation changed so that it is introduced into our building code. Our minister is very keen on doing so, which is useful because often there is not the political will, even though there is maybe the societal mandate for it. And I think that's probably something that all jurisdictions face at different times.
Yes, yeah, no, thank you. Yeah, it's a pleasure. Yeah, I've been working with Victoria closely on developing overheating model for New Zealand, and yeah, it's a pleasure. And Richard is helping. He is like the private consultant that is developing the model, and we just share our data.
It wasn't me, Sally.
It wasn't me either. I'm sorry. I was just automatically thrown out. So I will very quickly, if I may, find the quickly finish off my presentation. Hopefully, you can all see this again. I was just think we have some basic. We are monitoring what's actually happening in the built environment with new buildings, and this does have relevance to some other aspects in terms of opening windows. There is interaction across. We organise our guidance for building regulations around the parts of the building regulations themselves. So there's interaction between all of our guidance, particularly with Part E sound. So we don't allow for, we don't assume that your windows will be opened if there is traffic noise outside. There's also the interaction with Part F ventilation. Increasingly, we are requiring there to be background ventilation in buildings that have a high level of that are highly sealed, that have a high level of in highly sealed buildings, we're requiring you to install mechanical background ventilation. And also we've got one that's reasonably contentious, protection from falls, in that we require, if you are using a window for bedroom ventilation, for overnight ventilation, we require a high guarding level. So it has to have there has to be a guarding level of 1.1 meters, which is relatively high for and higher than is required for an opening window in, for example, your sitting room. We also have, there's also, as I said in Part L, there's a balance between that, the energy efficiency, the air tightness that we require as part of energy efficiency, and the ventilation required as part of the ventilation required as part of both overheating and ventilation. And there's also elements of security in that if you've got ground floor windows, they must remain secure. And the final bit with this was just to look at our active and recent research projects that we've got. Within the Building Safety Regulator, we've got a number of research projects underway. We also have what's not mentioned here because it is that we have, because it's a new form of regulation, it's a new form of guidance. It was only introduced in 2022. We're just now starting to look at the impact of this and how it's explained. And we've got changes in the design summer years. There's a new set of design summer years that have been published, and climate change is happening much faster than was anticipated when this guidance was drawn up. So we've got a major review of all aspects of the overheating guidance that is starting this year, and we would expect to produce the results of that, which will be recommendations for improvements to the guidance, possibly improvements to regulations, but definitely improvements to the or amendments to the guidance in late 2027. So yes, that's the end of this the presentation.
Thank you very much, and thank you for being ready in such 5-minute notice. I was very.
You're very welcome. I'm poised ninja-like to be able to present on overheating at any given moment.
Nice, very nice. Thank you for this. I noticed that Richard has a question in there, and then we'll go to Michael. Richard? No, you are still muted. Yeah, yeah.
I've finally got it. It goes on and then it goes off. It's the static on my finger. When I was looking at the metrics, one of the things that we frequently have is that we put in regulation or provisions, and then how is it that we measure it to see if we were successful? We have had a couple of national studies, which we call with brands. It's the Building Research Association New Zealand, called HEAP 1 and HEAP 2, which is the home and energy provisions within buildings. However, new regulation in terms of overheating, trying to get metrics on that. What are some insights? What some lessons learned? What can we do better?
Yeah, we're still struggling with this as well. So there's because we have these two routes to compliance, one of which looks at the elements of your building, and one of which looks at the output from a dynamic simulation model, which uses the dynamic simulation model has a metric of overheating temperatures. So we are edging towards attempting to monitor both of these. We're working with the statisticians to look at for that simplified view, which regards what glazing do you have, what glazing is able to open, and we're looking to use the detailed but very error-prone information that we get from energy performance certificates. And as a government, we've got access to more detailed varieties of this, and we're starting to look at can we use that to look at what glazing on which aspect was introduced. But that's very very early stages for that, and that was part of the column charts that I showed, which looked at the amount of ventilation and the amount of air conditioning that is installed in buildings. That's the initial exploration about can we use that. So that's one bit about looking at using EPCs to look at what's actually installed in buildings, because we've got that as a route to compliance. The bit about looking at the metrics that use temperature and temperature and hours at a given temperature overnight, much harder. We're starting to look at we've provided some funding to a large-scale academic study known as HEARTH, HERTH, across the UK. We've provided some funding to this to allow them to try and track down buildings that have been installed under these new this new regulation regime, and to examine what the actual temperature is in a selection of those buildings. But we are really struggling to find. We've asked them to try and identify 30 buildings that have been constructed to the latest building regulations, and we're struggling to find that. And we would also anticipate that, given the difficulties in measuring temperatures in real buildings with real people's behaviour, we will struggle to get results even from those 30 buildings. But what we are anticipating that will provide the richest information for us is that we will actually get access to the residents in those buildings, and we will be able to ask them about what their experience of overheating is, because this also gets tied into the other big form of data that we have is the English Housing Survey, which has, because it's been going for 100 years, and people are asked within that, what is your experience of overheating? It's only one question, it's very subjective, but we do have it, and it does, the questions vary from year to year in the English Housing Survey, but we do have that information. So we do know about existing buildings, and we do know that experience of overheating has not been diminishing. It's recorded by age of building, so we know that it's not going down. People are still about 10% of people in the most recent buildings experience overheating, and that's the same as building pre 1900 buildings. So old buildings and new buildings are still experiencing overheating. We do know it's not as horrific as it was in the buildings in the 1980s. They're the worst. They're the worst for everything. So it's all the fault of the Conservative government in the 1980s. But yes, it's a continual struggle and effort to try and track down those metrics. And I'm afraid we don't have any magic bullets, apart from the fact that it's really hard getting real-time data from the most. It's really hard getting real-time data, and getting consistent monitoring is very difficult, quite apart from the fact that we generally identify, even when we track down buildings that have been built to the most recent building regulations, it is very common, and we acknowledge this, that the ventilation systems that are installed have frequently been badly installed, badly commissioned, and don't fit with what they were supposed to fit with.
Thank you, Sally. Michael.
Thank you, Sally. So my question was around that bar chart that you showed. That was when we lost contact with you. So it was just to ask if it was showing the choice of compliance method that over time, or what? Yeah, sure.
No, it didn't show that. It didn't show that, but we do have, because if you don't, so we don't know what the compliance method was. We can take a number of assumptions from it, and one of the things we do know is it's very, very difficult to comply with the simplified method if you're in London, and we were mainly focusing on London because that's seen as being one of the hardest places. So but that's something that we're working with the statisticians to see what we can look at next. Bearing in mind that, as I said, we've got a major review of the operation of how the guidance is being used and how we can adapt it for the future. And there's a high chance that what we currently describe as a simplified method will no longer be fit for purpose, and it may have to be entirely adapted. So we're just limited to how much analytical resource we want to put it looking on something that might disappear.
Okay, thank you.
Thank you. Vincenzo?
Yeah, thank you, Sally. I have a question about the approach based on building simulation. I mean, I understood that the tool has been developed by CIBSE, but is it based on a specific engine or a specific standard, or it is?
No, it's not. We leave it up to third-party software developers to use the CIBSE TM59 describes a model. It doesn't describe the how the calculation engine that's used to generate that model. That's left up to third-party software developers to provide it. The reason we used TM59 was that it was already used as the basis for a number of existing dynamic simulation models that are on the market. So we don't comment on or validate those dynamic simulation models, and that is also part of what we're going to be looking at in the review of it. Is we're going to be working with CIBSE to see how do they feel their model is being used in a variety of different dynamic simulation models.
Thank you.
Sally, can you give us one example of a simulation model that's on the market that respects CIBSE without implying that you're?
No, I'm afraid I can't. I don't have it on the I don't. Yeah, I don't have it available. Sorry
I can find it using Google anyway.
Yeah.
So excellent. So this brings us to the end of our meeting. That's it's amazing. When we started this off, I didn't think that we would get so much rich information across the world. It's really impressive. So our next meeting is May 11th. I think it's best to limit this to 2 hours so that people can stay the full 2 hours. So chances are, like, we have 4 simulations or 5 simulations next time. So I'm going to keep it to 3 simulations and then plan another meeting following that. Is that a reasonable thing to do? Yeah. Okay. Excellent.
Yes. Do you also add Italy to the list of presentation? Okay.
Yes.
Thanks.
So,
Thanks a lot.
and there might be one from Japan. So this is going to, this is generating a lot of interest from everybody. So anyway, thank you for staying until now. Roberto, if you could send me your presentation. I received the one from Michael and Louis. So if you could send me that would, sorry, that would be great. I'm going to put all these things on our website as soon as I can, and just build it up with the subsequent meetings. Very good. Thank you for staying 2 and 20 minutes. I don't know what time is in New Zealand at this point. Probably it's midnight. And in Australia, quite late.
Yes, late evening. It's fine.
Okay. Thank you. It's always a pleasure. Take care.
Thank you.
Thank you.
Bye.
Bye-bye.
Bye-bye.
Take care. Bye.
Goodbye.